Hey everyone, welcome back. Today's day 5 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, breaking each down on video and sharing with all of you on YouTube. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was in statistics and machine learning. Currently, I'm at top 0.3% on LeetCode, and like most of you, I'm a big fan of LeetCode as well. Over the last few days, we have tackled sliding window, two pointers, prefix and suffix based problems, and we have also tackled problems based on strings. Today, we will focus on stacks and we'll try to solve problems based on monotonic stack, next greater or smaller elements in the stacks, and problems of such natures. These problems will teach us structure, flow, and how to handle state across elements, which is key in interview. Before I begin, if this video helps you, please drop a like and also consider subscribing to my channel. You can also share my videos with your friends who are struggling with these problems and might need some additional insights or help. So with all that, let us begin today's problem. So we will be tackling LeetCode 503, next greater element, part 2. The part 1 of this video of this problem has already been done by me, and you can take a look at that. This problem states that we have been given a circular integer array nums, such that circular integer array means the last element of the array has a next element as the first element of the array, okay? As in the ends are connected. And we have to return the next greater number of a number x. Cool. So what are the constraints? The constraints are as given this description, and these are the examples that we can see, and it asks us to return the next greater element for every single element. And if for some example, if for some element, if there are no next greater element, then in that case, we will assign their next greater element to be -1, okay? Keeping all those things in mind, let us go to the dashboard where we'll try to investigate and try to dig in deep and try to find an optimal solution for this problem. So I'm on the dashboard right now. We have been given nums, and we know that this is a circular array, okay? Which means if I am at the end of the array over here, then the next element for this is not something null or irrelevant. In fact, since the ends are connected because this is a circular array, so its end will be this one, the beginning of the array, okay? And we have to return the next greater element. For example, the next greater element for 1 will be 2 because of this thing, right? For this end, the next greater element for this one will be 2 because the array is linked like this, and we'll again scan from the start and we'll find 2. Okay. And if you look at 2, there is no next greater element for 2 on either of those sides. So the answer is -1 for 2. Okay. Before I begin, just a matter of fact and something that I want you to keep in mind is this formula, index mod length. Every time we have been asked, or if we are ever asked to deal with arrays that are circular, and we want our index to stay within the bounds of this array, as in if we want our index to wrap within this array, we will use this formula, index mod length, okay? It will help us to wrap around the length of the array. I will tell you what that means. For now, when I tell you that this array is circular, in other words, it can be thought that this array, you can visualize this array by duplicating it, as I have did over here. 1 to 1 was the first part of the array. Then again, I did 1 to 1. And it is quite convincingly pretty clear that this represents a circular array. For example, if I am at the end, then what will be the beginning? What will be the next element after 1? Instead of going back and scanning, I will just traverse the next element, and it should be pretty similar to this one, correct? And instead of going on to the left and finding 2, what I will do, I will just scan 2 elements ahead and I'll find 2, correct? So if I just double the length or just duplicate the entire array, it will give me the duplicate in such a manner that these two are linked, and we can assume that this entire array is one such array where they are just representing the circular array of this original part, okay? And if I do that, the index will go as follows: 0, 1, 2, 3, 4, 5. But hey, do you notice one thing? Our original array just had 3 elements, but our duplicated array that we have doubled in size has 6 elements. So how do we fetch element at index 5? We know that in this array, we cannot access index 5. So in order to access index 5, we have to wrap index 5 within the length of this array. And how do we do that? Using this formula. For example, 5 mod length of this thing, which is 3. It will give me 2, correct? And 2 is the actual index, which is pointing to 1. As you can see, index 5 is pointing to 1 over here. And index 5, when performed under this operation, it will get wrapped and it will point to index 2, which is 1. Okay. So I hope you understood the significance and the importance of this formula and what it is actually doing. Okay. So with that in mind, let us do a dry run for this problem and we'll see how it goes. Before I begin, this is the answer array that we have to return. And we will also need a stack for this problem. Since this problem deals with the next greater element, every time, just remember this thing, every time we have to find the next greater element, we will think along the direction of monotonic decreasing stack. Why monotonic decreasing stack? Because what is the monotonic decreasing stack anyway? Monotonic decreasing stack is a stack that assembles or collects elements as long as they can until and unless it encounters an element which is greater than the top of the element. Okay. If such is the case, then we'll start popping out the elements from the top, okay? As long as the outer element remains greater. I will repeat once again. Monotonic decreasing stack is a stack that contains elements in decreasing order such that if we encounter an element outside the scope of this array, which is greater than the top of the element, in that scenario, what we'll do, we'll operate from the top of the stack. Generally, the operation is performed by popping the top of the element of the stack, and we go on popping as long as this remains the greater element, okay? So that is what we are going to do in this case. First of all, we have a stack over here, and the structure of the stack will be a pair where the first value will be the number or the value, and the second value will be the index of where the value is stored in the array, okay? So now, okay, so let us start this scan. I'm at this index, okay? The first question I will ask is, hey, is my stack empty? If the stack is empty, we'll try to push the element present at that index, okay? If not, then we'll do some operation. Right now, the stack is empty, so let us push the element at 0 index. We'll push it by accessing the value, which is 1, and accessing the index, which is 0. We'll then increase our pointer, we'll come over here. As I told you earlier, right? Monotonic stack is such a stack, monotonic decreasing stack is such a stack where we will keep on assembling or pushing to the stack as long as we encounter until we encounter an element which is greater than the top of the stack. If we encounter an element which is greater than the top of the stack, in that case, we'll operate from the top of the stack generally by popping that element out. Let us look at this case. We encounter 2. We ask ourselves, hey, is our stack empty? The answer is no, our stack is not empty because it has some elements. Then the second question we'll ask along with the first question is, hey, is the current element that I'm looking at, hey, is it greater than the element present at the top of the stack? What is the element present at the top of the stack? 1, right? Because 0 is just the index. So 2 is greater than 1. In that case, what I will do, I will pop this part, okay? And once I do that, I will come to this result part, the answer part, okay? And in this answer part, using the index that was popped, which is 0 in this case, right? I will assign the value, the current value that I'm looking at index 0. Why? Because this value is responsible for popping this element. Why is that responsible? Because this value is greater than 1. And since 1 was present at index 0, so at index 0, I'll come and since we have to find the next greater element, so I'll mark 2 over here, okay? Which is coming from there. Cool. So at index 0, I'll mark 2. And since this has already been popped, and once that is done, our stack will become empty. Then what I will do, I will push the current element, which is index 2 at value of, which is value 2 at index 1, okay? Then my pointer will increase and it will come to this place at index 2. So I will ask, hey, is the current element greater than the top of the element? The top of the element is 2. The answer is no. The current element is not greater than the top of the element. In that case, what I'll do, I'll push the current element along with its index value, which is 2. Notice one thing. Till this part, we have exhausted or completed the entire length of the original array, right? But in this case, we have doubled the length, right? So, and we will be accessing this index, which is beyond the length of the array. Now we have to make sure that we use this formula, okay? Because we are accessing those indices which are beyond the length of the original array. So by using this formula, we'll be able to wrap these indices within the actual length of the array. You will see what I mean by that. And you will see that in action, okay? The pointer increases and it comes to this part. First of all, this index is greater than the length of the actual array. So I will take the mod with the length. The length is 3. So the mod is 0. So this index will be interpreted as index 0. Okay. And I ask, hey, is the top element, is it greater? Is the current element, which is this, hey, is it greater than the top of the element? The top of the element is this part, 1 itself. And the answer is no, it is not greater. So what I will do, I'll push 1 and at index, at what? At index 0. Okay. Go. The pointer moves and let me change the color. The pointer moves and it comes to this part at index 4. I'll do 4 mod 3. Why 3? Because 3 is the length of the original array. And once I do that, the mod will keep me the value of 1. So index 4 will be treated as index 1. Okay. Now I will ask, hey, is the current value, which is 2, is it greater than the top of the stack, which is 1? And the answer is yes. If that is the case, then please pop out the top of the stack. The top of the stack is popped out. Once the stack top of the element is popped out, hey, using its index, which is 0, please replace the value present at index 0 in the answer array with the current element that we are seeing. So what do I do? I replace 2 with 2 itself, okay? It makes no sense, but we're doing it because 2 and 2 are same anyway, okay? Since this element has been popped out, what is the next element? This is the next element, right? We ask the same question again. Hey, is the current element, which is 2, hey, is it greater than the top of the element on the array, which is 1? And the answer is yes, it is greater. Then please pop this element. Once I pop that, what is the index associated to this element? It is 2. So I come to this array at index 2, and at index 2, I replace the value with the value that was responsible for popping, which is plus 2. Okay. So plus 2 goes over there, and this has been popped out completely. Okay. What is the top of the remaining element of the stack? It is this one, right? I ask, hey, is the current element, which is 2, hey, is it greater than the top of the element that we're looking at, which is 2? The answer is no, it is equivalent. Okay. So in that case, what I will do, I will just push this element to the stack 2. The value of index was 4, but since I did the mod to wrap it in the array, its value became 1, as you can see over there. So along with this value, the index value will be 1. Okay. And again, the pointer increases and it comes to this part. Let me change the color again. And as we see, 5 is far ahead, greater than the actual length. So I'll again take the mod 5, mod 3. It will give me 2. So index of 5, it will be represented with index of 2. And currently I'm looking at this point, which is 1. Okay. I ask, hey, is 1 greater than the top of the stack value, which is 2? The answer is no. So in that case, what do? I push that value along with its index on the stack, which is 1. Cool. Index is 2. Then I move the pointer and we see that we go out of the array and we stop. And once we stop, we return the actual answer. Okay. By the way, this answer array, which was initially empty, will not be such a case. We have to pre-fill this answer array with -1. Okay. So -1 will be there and its actual answer will be minus +2, -1, and +2. Okay. This is something which is exactly what is outputted over there. Okay. I hope you understood everything that I was trying to explain, especially how the wrapping is done using this part and how I have taken that over here as an example from all these indices over there. Okay. I also hope that you understood how these are getting placed in the stacks and the importance of monotonic decreasing stack. In monotonic decreasing stack, we will go on pushing the values as long as the values are in decreasing order. But if we encounter a value that is greater than all of those values, we'll keep on popping it. Okay. We'll go on popping all those elements and we'll keep on popping until the value in the stack are greater, right, than the value that we're looking at. Okay, cool. So yeah, that was all there was to this problem. I hope you understood it. Let us go through the code pretty quickly. So the first thing that we're doing is we are declaring the result array. Initially, we are assigning it to the -1, and its length will be the length of the nums. Okay, it is the same thing that we will be returning towards the end. Then we declare a stack, which is an empty stack initially, and the value that will be pushed in the stack will be a pair, where the first thing will be the value of the actual number, and the second thing will be the index where that number is present. Okay, then I scan through the entire array twice of its length, which is something that we were doing over here. Why twice? Because we wanted to have a very intuitive understanding, and instead of wrapping directly, we wanted to traverse twice and wrap it using mod inside of the loop. Okay, which is what we are doing over here. We are wrapping the current index, which is iterator I, by the length, and this wrapping makes sure that it remains within the length 3, or whatever the actual length of the array is. Okay, and once that wrapping is done, we ask ourselves, hey, is the stack empty? Using the while loop. If the stack is not empty, then we ask, hey, the current element that we're looking at current index, which is coming from here, wrapped version, if that current element, if it is greater than the top of the element on the stack, if that is the case, then please pop out the top of the stack. And once the top of the stack is popped out, using the index that was popped out in the result array, at that index, please replace the value of -1 to the value of the current element that we're looking at current index. And we keep on popping this using while loop as long as it is possible. And then once we are out of that while loop, we append the current value in the stack at the current index. And once this entire loop is exhausted, we come out of this loop and return the answer as a result. Okay. So the time complexity of this problem will be order of n from here, which is linearly bounded, and order of some factor. I don't want to invest a lot of time right now into computing the factor. I will just call it order of f times order of n. Okay, and the space complexity is order of n because of these three things. Okay, because of these two things. Cool. So yeah, that was all there was to this problem. I hope you enjoyed my explanation, everything that I was trying to explain, especially the monotonic stack, how the indexes are wrapped, and how we are pushing the stack, and everything that I try to visualize over there, and the code part itself. Let us go to the LeetCode dashboard and we'll try to submit the solution to this problem and we'll see how it goes. I've already coded and submitted a solution, so I'll just copy and paste my code, which is something like this, and I will just run it down and we'll see if it gets accepted. And as you can see, it passes all the test cases and it has been accepted. Cool. So yeah, that was all there was to this problem. If you have any more questions, or if there was any part that you did not understand, please let me know in the comments and I'll be more than happy to help you out there.